Number 6, integrating x squared e to the x cubed. Might be able to do it in your head actually, but I don't. I'm just going to use a substitution of x cubed. I know that's a substitution because in my head I've already seen that that differentiates to give 3x squared, and I can see where this is going. Those x squareds are going to cancel in a minute. So rearrange to get du over 3x squared, and let's rewrite this as x squared e to the u, instead of a dx, writing du over 3x squared. And there you go, those x squareds are cancelling. We're just integrating 1/3 e to the u, which just goes to 1/3 e to the u. Drop u back in, and we've got that bit there. So it's 1/3 e to the x cubed, and put a plus c in because, again, it's an indefinite one. So for part B, we're trying to find out the integral from minus infinity, the integral from minus infinity to 1. And so what we're going to say, this is the limit as t tends to minus infinity of the integral between t and 1 of x squared e to the x cubed dx. That is the limit as t tends to minus infinity of, what did we just get? We got that thing there, didn't we? 1/3 e to the x cubed from t to 1. And so, last bit, stick a 1 in there, we get e to the 1, so we get 1/3 e minus 1/3 e to the t cubed. So, as t tends to minus infinity, e to the minus infinity, well, e to the t cubed, well, that would get absolutely massive. That would get to infinity. No, sorry, minus infinity. Whoops. Sorry, it's going to minus infinity. I don't want to redo it, just at the end there. So this is getting really, really, really small. E to the something really, 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 really small. So this thing here tends to 0. That tends to 0. And the answer is going to be 1/3 e. Sorry, I garbled that at the end there. Just convert it there. Yes, it does converge. Do I need to do that again? Just saying here, the little thing I was just mucking up there. It goes down to minus infinity. So this is minus infinity. E to the minus infinity, basically 0. So this thing here does converge. Sorry.